Today we discuss on important topics related to adjoint of linear operator. Basically, we discuss now in our product space, obviously connected with linear algebra. Now we also discuss least square approximation. Okay, we know about that least square approximation. We also discuss now. Okay. If you have not an idea, not a problem at all. This one is too easy, and obviously from primary level, from basic level to we discuss now. Okay, so first we get, well, so first two, that means an experimenter collects data. Okay, that means someone's collect data by taking measurements here. Measurements y1, measurements, okay, y1 y2 dot ym at times t1 t2 dot tm respectively. Okay, then what happened, then we also this data plotted in some plane. Okay, so we first collect this data, it's measurement y1 y2 ym at times t1 t2 tm respectively. Then we also, that means this data we plot it as points in plane. Okay, here we write t1 y1 t2 y2 dot tm ym. Okay, are plotted as points, are plotted as points, okay, in the plane. Now also what we do, that means there exists an essential relationship between y and t. We also see that one relationship, okay, between y and t. Okay, then what happened, we write it this relationship y equal to ct plus d. Okay, where ct, what ct is the, that means constant. We have to find constant c and t, c and d. Oh, sorry, not t, t is variable here. So also how this c and t we find, that means we also find the c and d, so that the line, so that the line, okay, y equal to ct plus d, y equal to ct plus d represent the best possible fit to the data collected. Okay, this one represents the best possible fit, to the data collected, okay, understood. Now we also here write in this way, we draw this figure. Okay, this one is what, here t, here y, and this one is, we draw this line equal to what, y equal to ct plus d. Okay, then what happened, this one is obviously ct equal to 0, so this one is d, and in this way we also done it in better way. So now obviously here any point ti and c ti plus d, understood. And another point is what, here t1 y1, Okay, in this way. And here 1 point t2 y2, and in this way here we write tiyi. Okay, tiyi, and here we also write ti plus 1 yi plus 1 in this way. Okay, in this way we also represent this plotted graph and how these points are scattered here in this plane. And we also that means as assume one line, straight line, which are obviously fit for this data. That means this collection of data. Obviously we shows that we represent this best possible fit to the data collected. Okay, so now we also going to discussion then what happened. Then we also estimate to fit, then some error is found. Okay, that means if we estimate of fit, here we write estimate of fit. Okay, estimate of fit to calculate the error, to calculate the error. Okay, calculate the error e. Okay, that represents the sum, that represents the sum, that represents the sum of the squares. Okay, of the vertical distance, of the vertical distances from the point, of the vertical distances from the point. Okay, to the line, that represent the sum of the square of the vertical distances from the points to the line. That is what we erase our portion and going to further discussion of that. That is E equal to what happened? I equal to 1 to m. I equal to 1 to m. Here yi difference c, ti difference d. Okay, whole square. Understood? That means to the power 2. Y difference c, ti difference d to the power 2. Okay. Then what happened? Thus the problem is reduced to finding the constant c and d that minimize e. Then what our target? Our target is finding c and d to minimize e. That means this error minimization, and obviously we have to find c and d. Understood? Then what is happening here? For this reason, the line Ct plus D is called the least square line. Okay, so we write here, for this reason, okay, the line y equal to Ct plus D is called the least square line. Okay, least square line. If we let if we let a equal to t11 t21 dot dot dot, here tm1. Okay, then what happened, and here x equal to cd and y equal to y1 y2 dot 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 ym. Then it follows that then it follows that what e equal to, here y difference ax square. Okay, norm of y difference ax square. Then what happen is, here we develop a general method, okay, to for finding an explicit vector x0 belongs to fn. Okay, so we write it here. We develop a general method for finding an explicit vector x0 belongs to fn. Okay, that minimize e, that minimizes e. Okay, then what we write here, that is given an m cross n matrix A, we find x0 belongs to fn. Okay, such that what, we erase our portion and going to further discussion of that. Then what happened is, here such that norm of y difference ax0, okay, less than equal to norm of y difference ax. Okay, for all vectors x belongs to, for all vectors x belongs to fn. Okay, and this method not only allows us to find the linear function, okay, that best fits the data. This method not only allows us to find allow us to find, okay, the linear functional the linear function that best fits the data, that best fit fits the data. Okay, that best fits the data, but also for any positive integer n, but also for any positive integer n. Okay, the best fit using a polynomial of degree at most n. Here, but also for any positive integer n, the best fit, the best fit, okay, using a polynomial of, using a polynomial of degree at most n, of degree at most n. Understood? Not a problem at all. So what is happening here? This method not only allow us to find the linear function that best fits the data, but also for any positive integer n, the best fit using a polynomial of degree at most n. Understood? Not a problem at all. In this way, we also discuss least square approximation. Okay, that means some collected data. Obviously, we also, that means plotted in a plane, and then we also fit, or we also, that means approximated this collection of data with a straight line. Okay, and then we find some error occur, and we also find this constant by minimizing this error. And this one is the process. This process is called least square approximation. Okay, and obviously in inner product we also do it better. Then we also represent it a x and y difference ax inner product square, non y difference ax square, or inner product of y difference ax, inner product of this one. This one is easy, this one is represent e, and we also find in this way. Okay, so this one is least square method, and this line is called least square line. Okay, so now today we stop here. If you get this type of video, please subscribe my channel. If you have any question, comment, suggestions, write it in comment box, and if you want to give like, please click on like options. Thank you. I stop here.